We've done this, and you'll see whenever we get through this that we've done it before, and I hope you'll remember. I think you'll remember. I called it base manipulation whenever we did it. So, I'm sorry. Tell me what you know.
That X is 3.
Because that's right, and they have to equal each other because if the bases are the same, then the exponents must be the same also, right? And so if we have things, maybe we have something like, we'll start out easy. Yes. Then I can just drop the bases and set the exponents equal, right?
Yeah.
We all agree that? Okay, so 2x minus 9 would equal 7, and I hope you guys can do that in your sleep, huh? Yes. No. Did you say 6? 8. 8. What happens? What if it looks like this? What? Please what? Good job. You just add them because it's the same properties of exponents that we've been doing, and that if the base is the same. So it might be that you have to combine together first before you can do that. So since these are the same base and I'm multiplying, I add these exponents together. So I get 5 to the 4c plus 1 equals 5 to the 7c plus 16. And if y'all don't need me to do any more than these on this, then I'm just going to keep on trucking it. If y'all remember how to do this. Okay. Remember, a lot of pre-cal is going back to these algebra 2 topics, redoing them, and then like making them a lot harder. That's right. So that when you see them in calculus, you go, oh, piece of cake. All right, 4c plus. So if you have x squared times x to the third, tell me what you do. Do you? So it'll be x to the fifth. Now, if you had x squared to the third, if it was power to a power, that's when you multiply. All right, so minus, I got negative 15 equals 3c, so c is negative 5. Everybody okay with that? Plug back into what? No. Tell me when y'all got that so I can go to the next little part. No, what? That's just an intro. Y'all calm down now, calm down. We'll get there. It'll get hard in a minute, just wait. Now what if they don't have it? So same base is easy, right? Just set the exponents. But what if the bases aren't the same? What? You got to manipulate them. What if I have something like this? Uh-oh. How can I make them have the same base? And it may not be that, I mean, I might have to manipulate both of them is what I'm trying to say. It might not be just one that I have to manipulate. In this case, I can just manipulate the 81 to have a base of 9, but it could be that I have to manipulate both. So here I could make this 9 to the 4y minus 26, 9 to the second. Here's the rule, though. Be very careful. You can never change the value of the number. It would always have to equal 81. You can write it a different way, but you can't change its value. Say again. Yes. So 4y minus 26 equals 2. Am I going too fast? Sure. Okay, y'all try this one. Don't be scared. It always gets harder. I spy a quadratic. I don't know. What do you think? Absolutely could. I could look at all these and go, okay, I can make them all have a base of 12. Do we agree? 1 over 12 is the same thing as 12 to the negative 1. And then I've got 4x plus 3. You got to remember all those little Aggie exponent properties. That's right. All right, so this is 12 to the negative 4x minus 3 times 12 to the x squared, 12 to the 2x plus 13. Now I'm going to add. So on the left side, I'm going to have this plus this equals this, right? Because once all the bases are the same, drop them off, combine them, and drop them off. So I've got negative 4x minus 3 plus x squared equals 2x plus 13. How in the heck do you solve a quadratic? That's right. Make it equal 0 and then start running through everything you know to solve a quadratic. We could factor and solve. We could complete the square. We could graph and find the zeros. We could quadratic formula. You learned lots of different ways last year, right? Right. Minus 6x minus 16. Oh, negative 8 and 2. What? I like to win. Because that's something y'all know how to do. So you just find the 0. Yep. 2 solutions. I'm fitting to give you a hard one. You thought that one was hard? Oh, Brian. Wait till you see what's coming next then. When you find the base, don't blurt it out. Oh, this one's easy too. Woo, hiss. Yeah. I just want us to practice getting some bases because that to me is the hardest part. It's just 2 different problems. Find the common bases on both of them. Rewrite them with the common bases and then we'll solve together. Yeah. Don't solve it, just manipulate it. Yeah. I don't know what y'all talking about. So I would write, what's your common base here? 8, right? 8 to the what is 512? So I would do 8 to the third, and then y squared is here. And so what happens is this just becomes 3y squared. 8 to the what is 64? 2. So if you need to flip it, negative 2.
So I get 64 to the negative 1, negative 3y. So then I get 8 to the second
Times. You just got to multiply them. Negative 1, of course, here. So you got plus negative 5y squared, or minus 5. So make sure you can get to this point. 8y squared plus 6y equals 0. I can take out a 2y. Because remember, the goal is solving for y. Yeah. It just has to keep its same value. So you can rewrite it a different way, but it still has to be 1 over 64 at the end. Well, what's 8 to the negative 2? 1 over 8 squared, which is 1 over 64. Right. What? Negative 6y, that's negative 5y squared. So I added the 5y squared here, and I added the 6y. Ooh, y'all didn't like that one as much, did you? That's easy, Miss McGee. We know how to do this. No, I haven't done the purple one yet. Tell me when y'all are done with the red one. Yeah. Yeah, when you're done with the red, move over to the purple and see if you can do that one. Oh, that was just... There you go. Why can't you use 4?
Because of the 32.
The 32. So see why this one was a little bit harder? Your gut instinct probably was to go with 4, but you can't, because these two are both, you could rewrite as a base of 4, but this one you can't. So I had to keep looking. So base of 2 works here. 2 to the what is 1 over 16? Negative 3. Right? No. 4. Sorry. X plus 7. 4 to the what is, 2 to the what is 64? 6. We got an X plus 5 out there. What about 32? Negative 5, so says Christina. This plus this equals this. Yes? Wait. So negative 4 times x plus 7 plus 6 times x plus 5 equals negative 12. Yes. So negative 4x minus 28 plus 6x plus 30 equals negative 20. Easy peasy? Thank you. I was waiting on it. Bless you.
So that's not what I did. I studied to do that, and then I found that like two X's.
How'd you get two X's?
I got two X and then I added anyway, I still had to get 22X plus, and then that's not two.
Well, this is never gonna be 0, so it doesn't impact your answer. So then you just have x equals negative 11. So you'd have gotten the same. Other questions? Somebody is yelling. All right, ready to do P. So yeah. This is the second part. What's the problem here? There is no way that I can write both 3 and 80 with the same base. Bless you. Do you agree? That's if I have a log. But you're right. I'm going to use a log. You're exactly right. I'm going to use a log. So how am I going to use a log? What's going to happen? Log base 3 of 80 equals x. Because remember, if your exponent is unknown and you want to know it, then change it to a log because logs are exponents. Okay, so once we have it in, yeah, that's the answer. This is the answer. Whatever you get on your calculator. So you have to do log 80 divided by log 3. It's the, yeah. 3.99 there. Okay. Now, it could be that there's multiple things. Always, 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 before you do any of this, isolate. What does isolate mean? Get it by itself. Isolate the exponential piece first. This is why we combine this. Approximately. Yep. But you got to isolate it first. So, for instance, let's make it even harder than that. Less or not harder. Oh. Tell me when you got it. I haven't wrote it yet. All right. Solve for x. Minus 25. That's easy first step, right? 75 plus 8 would be 83. It's kind of what I do. Wait, well, I wasn't paying attention. I'm sorry. What'd you say? Thank you. Yes. So natural log, which is log base e, natural log of what? Equals. And now yep. These are going to be calculator problems. I'm going to put log 83. No, that's fine. I got 1.47. What did you guys get? Okay. One more thing. Say it again. Yes. What? I know. I'm trying to decide.
Where's the
I can't isolate the log if the exponential piece if there's more than one. How am I going to isolate it? Uh-oh. Turn them both into a log. I can't do the same base. 2 and 3. Okay, not change it to a log, but take the log of both sides. In other words, log and log. Why in the world am I going to do this? Now they have the same base. It's log base 10, but how does that help me? What is that going to do? This is the new stuff, by the way. This is the pre-cal stuff. Can't. You're thinking right now. Here's what I'm going to do. I am going to make it equal 0. I'm going to move it over. What happens if I condense it? Divide what? Some of y'all did not get this right on your quiz. I did glance at that. When you condense, right. Well, I only, when you condense, you'll only have one log. It won't be log over log. It'll be log of the argument over the argument. So 2 to the x plus 5 over 3 to the x minus 2. Do we all agree that that has been condensed now? All right. So we took the log of both sides. We got the logs together. Get logs together.
So we always condense.
And then we condensed. Any ideas what we're going to do now? How? You're right, we solve. How?
Maybe now we subtract.
Exactly right. Change forms. Y'all are still looking at me like it's not going to work. What? Change the form, what happens? What's the base? Hold on. Equals. Oh crap! I messed up. I'm back where I started. I'm back where I started.
No, you're kidding.
No, it's not. Hold on. I have to write it. Not all of them. Once we take the logs of both sides, I had to write it down. I haven't done this in a long time. Once I take the log of both sides, so pick up right here. All right, so my brain's in calculus mode. Okay. All right. Once we're at this point, do the power rule. And I'll show you why. Well, as soon as I did this, it made complete sense why I did it. All right. Take this, bring it around. Take this, bring it around. Okay. So I've got x plus 5 times the log of 2 equals x minus 2 times the log of 3. Do we all agree? I'm sorry. I sound sorry. That's on me. And I was just like, this is what I did. I have, I know. Therapy. All right, here's what we have to remember. This is just a number. Log base 10. This, just a number. Okay, so what you can either find it and put it in here now. What I would do is I would say, okay, if I divide both sides by log 2, and I'm going to do this in 2 steps just so you see where it's coming from. I do as much as I can without the calculator, and then I'll pull the calculator. Oops. Sorry. Now I'm going to divide both sides by x minus 2. You crisscross them essentially, kind of, yeah. Because that's going to cancel them out here. So I end up with x plus 5 over x minus 2 equals log 3, which is just a number, and log 2, which is just a number. Now I'm set up to solve. Well, crisscross, I'm fixing to crisscross, but crisscross is not really the right thing here. You get all, yeah. You need to get all the x's on the same side with nothing else. So I just divided by these whole chunks right here. I divided by this whole chunk, and I divided by this whole chunk. Okay, you understand the log 2 division. And that brought us to this point. All right, so first let's get a decimal for this. So we don't have to keep worrying about this. 1.58. Now I got this rational function I got to solve. Gross. Where'd I lose you? I didn't follow that. Yes. Mm-hmm.
Wait. So if I just okay, you find the line. Yeah, just find what that line equals and then distribute the way.
So you're doing solving like, yeah. We're solving for x. You guys should be able to solve that now. I'm gonna do a couple more examples like this since I flubbed up them, but yeah. Yeah. Oh no. What? Oh, I'm good. That's a 3. That's been a 3 the whole time. All right, whenever you move this all together, what'd you get for x? Approximately what? 14.1? Thank you. Let's do another one start to finish that I don't flub up. Wait a minute. I'm not going to make y'all check for extraneous. Minus 5, minus 1.58, and then divide by negative. Because that's got an x on it. And that one does too. I just took her word for it. Okay, let's see. Let's add 3.16 to get 8.16 equals, and we'll subtract this 0.58.
How did you get that?
This should 8.16 divided by 0.58, or yeah, it's 14.1.
Where's the 0.58? Okay, so I got it to where it was like x equals 1.58 x minus 18. So I got the same numbers as 9. So that changed. So when
I don't know what everybody's asking, to be honest, right now. 1.58x minus 1x is 0.58x. I don't think, let's do one start to finish so you see one. I messed this one up in the beginning. That's why I think y'all are really confused here.
what did you get? I got negative 13.2. No, negative 3. I got 14. Yeah, I got 14. And I did. I already had one the way I did it. 8.1 divided by 14.
I got 14.1 when I did it. Let's come back. Let's go to another one, okay? And let's work it together, start to finish. Here we go. 8 to the 2x minus 1 equals 5 to the x plus 3. Let's log both sides. And in fact, instead of logging both sides, let's make it even easier so that let's ln both sides. Since there's a log button on there too. It doesn't matter which one you do. It really doesn't. It's probably a good idea. All right, so I have log 8 to the 2x minus 1 equals log 5 to the x. I'm going to bring these exponents around front. So I have 2x minus 1 times log 8 equals x plus 3 times log 5. I'm trying to keep them separated for you here so you can see what's going on. Round 2 places. I was going to say, now this is the point where if you wanted to put a decimal in for log 5 and log 8, you can. What I'm going to do, and here's where y'all got lost last time, I think. I'm going to divide by log 8. Maybe if I do this together, you'll see. I'm going to divide by log 8, but I'm also going to divide by x plus 3. Yeah. I am trying, so.
It doesn't really matter which one. Like he did log 5 divided by 8 divided by log 5. Right?
Yes, but then you'd have to divide by this one instead of this one.
Okay.
Because you got to get the x's together on the same side and nothing else, and that's your goal. So the log 8's cancel on the left, and the x plus 3's cancel on the right. So I end up with 2x minus 1 over x plus 3 equals log 5 over log 8. You got it already? And here's where I would go ahead and get a decimal. Okay, so let me make sure I understand the other way that you're saying. I think what you're saying is the log of 8 is 0.903. The log, well, that just because that one ended in a 0, that's not the reason I did it. And I'm used to calculus has to go 3 decimal places. It's hard to get my brain out of it. Log of 5 is point, again, that one ends in, I'm going to do 699. Yes, you'll still get the, yes. You might be off ever so slightly from, it just depends on when you round, but yes, you'll still get the same thing. So if you did that and then you distributed, oops, that one doesn't have a distribute, and solve, yes, same thing. Well, that one, because this canceled. Oh, that one does distribute because you wouldn't have done that. Yep. All right. What is log 5 divided by log 8? 0.774. You can, yes. Multiply by x plus 3 on both sides. .322. Y'all following me now? This just blew up. This is because I wasn't prepared to teach this today. I thought I was teaching just the other. But this one's good. 1.226 equals 3.322. 1.226x. That's not the final answer. 2.71. 2 decimals fine. If you round it early on, you'll be a little bit off from us. Yeah. 2.71. Hold on, I'll work it out your way now. It will be if you, yeah, that's fine. Yeah. Okay, that one's definitely not right. All right, so I subtracted 0.774x.
I divided.
And I added 1.
Yeah.
Don't say that. Sure. I was fixing to rework it. I think Madison did it the same way you did too. Did you evaluate your logs in the beginning and distribute through? Yes. Surrounding. There is a lot of working parts for sure. Yes, no, maybe so. Should we do another one? Y'all say you're good. No. You what? All right. Well, I'll be here all day, folks, and tomorrow.